Good morning and welcome to the first lesson in a 4-part series of sequences. Hopefully you managed to download the worksheets and have a go at these starter questions. As always, we will start by going through the solutions to these. So if we focus on the top left question, we've been given a number sequence and I've asked you to write the next 3 terms in the sequence. So hopefully you looked at the sequence and decided that it is going up by 5 each time. So if it's going up by 5 each time, you can simply add on 5 to the term 18 and you would get 23. And then same thing, you're going to add 5 each time, so you should have got 28, and add 5 again would give you 23, sorry. Okay, 33. So hopefully you managed to add on 5 each time. Very simple, quite straightforward. Spot the pattern and do it to the sequence. And then it says, part 2, write down the rule of the sequence. Well, the rule of the sequence we just discussed is you add 5 each time, and that is all you need to do for that. So if I ever ask you just to write the rule of the sequence or describe what's happening to the sequence, you can just put it in a sentence. So you add 5 each time. If we move across to the top right question, it says if x equals 2 and y equals 4, what is 2x plus 3y? Well, the first thing that you need to recall here, what does 2x actually mean? 2x means 2 times x. And what does 3y mean? That means 3 times y. So if it means we need to times them and we know x is 2 and y is 4, we can do what we call substitute. Okay, so this topic here is substitute. We can substitute and replace the x with what we know is 2. So if I put some colour here, we're going to say x is 2, so we're going to replace this x with 2, and we're going to replace this y in here for this y. So what does that tell us? That tells us we need to do 2 times x is 2 plus 3 times y, which is 4. Okay, so the way I've written that, instead of writing 2 times 2, I like to put it in a bracket, and that just means that I need to do 2 times 2. Okay, so what is 2 times 2? 2 times 2 is, so this equals 4 plus, what is 3 times 4? 12. So we just need to finish this question, we need to do 4 plus 12, which is 16. So the answer to this question was 16. So substitute will be a very, very useful topic for us today. So just recall that substitute means that we are essentially replacing, you replace letters, unknowns, with values, number values that we've been given. So we were given 2 values, one for x is 2, one for y is 4, and we just replaced them in and times them together because we knew that 2x means 2 times x and 3y means 3 times y. Moving on to the bottom left question. More fractions. So hopefully you're starting to get comfortable with fractions. If you still haven't watched the fraction series, I'd definitely recommend it if you struggled with either of these 2 questions. So this is asking us to do 4/5 plus 1/3. Well, the first thing you should always check when adding or subtracting, do I have a common denominator? And we don't. The bottom number, the denominator, is not the same. So remember, we need to make it the same. So I showed you that you can write out 2 blank fractions, and we're going to make it the same. So you can either think about what 5 and 3 go into, or you could draw this, which will help us. What is the denominator going to be? It will be 5 times 3, which is 15. Alternatively, you could have just thought, what does 5 and 3 go into? 15. There are other options, but we always want to sort of go for the lowest if we can. And then what goes here? Well, what goes here is 4 times 3, because what did I do to 5 to make it 15? I times it by 3. So remember, whatever you do to the bottom, you do to the top, so I need to times that by 3. And this is all this little line system does for you. You just follow the lines and fill it in. So 4 times 3 would be 12 here. And what did I do to 3 to make it 15? I times it by 5, so I must times the top by 5. Alternatively, following these lines tells us to do that anyway. We're going to do 1 times 5. Okay, so 1 times 5 is 5. Now we have a common denominator, which is good, which means we're allowed to add them now. Okay, it's okay for us to add. So you keep, remember, the denominator the same, and you add the numerator. So 12 plus 5 is 17. Hopefully you realised this is top heavy, improper, so we always want to change that into a mixed. So how many times does 15 go into 17 whole? Well, it'd just be 1 whole 1. Remember, the denominator will stay the same, so we've got 15 still. And when you need to work out what's left over, well, 1 whole 15 would be 15. How do you get from 15 to 17? There would be 2 left over. Okay, so the answer to that, either of those are correct. I would want you to put this mixed number as your answer though, because it is top heavy. Moving over to the final question on fractions. We have got 2 1/3 divided by 3 3/4. So the first problem here you should realise is we have 2 mixed numbers, and we discussed in the previous lessons that we should always change mixed numbers into improper fractions, and then also we have a divide. So we'll talk about the divide in a minute. Let's just get these changed. And if you recall, to change a mixed number into an improper fraction, you do the denominator, so 3, times by 2, which is 6, and then you add the numerator, so plus 1 is 7. Okay, so you do 2 times 3, and then you add the numerator. So 2 times 3 is 6, plus 1 is 7, over the original 3. This one we could always just fill in. The denominator is going to be 4. It's going to just be the same. And the top is going to be 4 times 3 is 12, plus 3 is 15. Okay. So again, 4 times 3 is 12, plus 3 is 15. So now we've changed them into improper fractions. Now we need to focus on the divide. Well, when you divide a fraction, you should be remembering, and hopefully you did, KCF. Keep, change, and flip. Okay, and you do it in exactly that order. So we're going to keep the first one, so that would stay as 7 over 3. We're going to change the divide to a times, and then we're going to flip, do the reciprocal of the last fraction, so that would be 4 over 15. Now, it's easy. Timesing fractions is the easiest one, you just times across. So that would be 7 times 4 is 28. And 3 times 15 would be 45. Is it improper? Is it top heavy? No, so we don't need to change it into a mixed. Can we think of any numbers that go into 28 and 45? To simplify, well, no. So this would be your final answer. Okay, so hopefully you managed to get all of those answers. If you didn't, just make sure you correct in what you struggled with. And if you struggled with any of this fraction stuff, really recommend go and look at the fraction series where we discuss all of what I've just gone through there. Okay, so that takes you onto sequences 1. So what we're going to look at now is the basics of sequences. Really, really useful for all year groups to know how to do what we're going to discuss in this lesson. And we'll start by looking at some definitions. So what I've written for you here is we've got a linear sequence, which is 2, 5, 8, 11, 14. Well, the first thing that I just wanted to discuss is, what does a linear sequence mean? Well, if we look at the sequence, let's see if we can spot what's going on with it. We're going from 2 to 5, which is a plus 3. And then we're going from 5 to 8, which is a plus 3. And then we're going from 8 to 11, which is a plus 3. So hopefully you can see the pattern, the rule of this sequence is plus 3. A sequence just means a series of numbers. And a linear sequence means, well, hopefully you can see there that this sequence is going up by the same amount. So a linear sequence means that the sequence goes up or down, because sequences can go down in numbers, they can get smaller. It goes up or down by the same amount. Okay, so in this case, it's going up by 3 every time. So it has to constantly go up by 3. A non-linear sequence would look like this. So if we had 4, and you don't have to write this, 4, 8, 10, 15. Well, if we check what's happening with this sequence, from 4 to 8 is plus 4, from 8 to 10 is plus 2, and from 10 to 15 is plus 5. So we would describe this sequence as non-linear, because if linear means it's going up by the same amount, this sequence clearly is going up by different amounts. So we would say it is non-linear. So a non-linear sequence is one that changes what it's going up or down by. A linear sequence is changing by the same amount every time. So what I want you to write down, I just want you to copy the sequence down. We've got 5, 2, 5, 8, 11, and 14. Okay, and we're just going to make some notes here. Some technical language we use. If we're focusing on this first number, we call this the first term. Okay, and you probably know that. That is the first term. The next one, the 5, would be called the second term. And the best thing about sequences is they're quite straightforward and they're quite logical. It almost seems too easy. The way we describe it, the way we talk about it, it's very, very simple. So the 8, hopefully you're thinking to yourself, that would be the third term. The 11 would be the fourth term, etc. And the 14 would be the fifth term. Okay, so we would say, if I said to you, what is the fifth term of this sequence, hopefully you would count like, that's the first, 1, 2, 3, 4, 5. And if I asked you for the fifth term, you would look at it and say 14. If I asked you for the third term, hopefully you'd look at it and say the third term is 8. If I asked you for the first term, you would say that is 2. Okay, so that's just sort of basic introduction to what you need to know about a sequence before we move on to something called generating sequences. Okay. So what we want to be able to do is make a sequence given some information. So the information that they give you, and we've written it here for you, is the nth term. And I'm sure you've probably heard that. If you're in sort of year 8 or year 9, year 10, you would have heard something called the nth term before. And students always don't really understand what it means. They just know that they have to find the nth term or use the nth term. So we'll just write a little definition. What does the nth term mean? It is it is an expression, and I'll talk about what I mean by that in a minute. It is an expression to find any term in the sequence. It's an expression to find any term in the sequence. And it's called the nth term because we use n as our letter. And I'll explain what this definition you've just written down means in a second. If you look at this first nth term that I've written for you, 3n. And the next one is 2n plus 1. You could have minus 3n plus 100. Okay, the nth term is just an expression, which is just a unknown or a number, so like 3n, that lets you find any term in the sequence. So let's link this to the sequence that we wrote up here. The first thing that we should write down and highlight is this n. What does that n represent? So if the nth term is a way to find an expression, or is an expression to find any term in the sequence, the n, we say, represents any term you need. Okay, so what do I mean by that? It represents any term you need. Well, this is where we can link, and this is where it's really straightforward. So this always seems a little bit, what's going on, until you see it on a sequence. What do I mean by represents any term you need? Well, if we focus on the sequence that we wrote down here, the first term is 2. So if n represents any term I need, we would say for the first term, n is 1, because this is the first term, so n would be 1. So when I'm focusing on the second term, if I want the second term, we would say n is 2. And hopefully you can see a pattern here. If I want the third term, what would n be? N would simply be 3. If I want the fourth term, n would be 4. If I want the fifth term, n would be 5. If I wanted the 100th term, n would be 100. If I wanted the 1000th term, n would be 1000. If I wanted the 232nd term, n would equal 232. So n is just whatever term you need. So if you wanted the second term, n would be 2. If you wanted the fourth term, n would be 3. Okay? And then we'll talk about how we use these in a second. So all you need to know right now is that the n represents any term you need, and it is as simple and as straightforward, and it always seems a bit too easy. If I want the second term, n is 2. If I want the third term, n is 3. If I want the fourth term, n is 4. So let's sort of take all of that and put it into action with example 1. Okay, and this will really hopefully become clear to you once you start seeing it being used. So example 1 says, generate the first 5 terms of 4n. So 4n, that is what we call, that's our nth term. Okay, that's the nth term that they've given us. And what do we know about the nth term? Well, we know that the nth term is a way to find any term in the sequence. And what is this question asking for? It's asking for the first 5 terms. Okay, it's asking for the first 5 terms. Well, this would be the first term, second term, third term, fourth term, fifth term. What do we know? How can we link the n to the terms? Well, if I want the first term, we've already discussed. If I want the first term, n equals 1. If I want the second term, n equals 2. If I want the third term, n equals 3. If I want the fourth term, n equals 4. And it is as easy as that. So how do we take that information, if I want the first term, n is 1, and link it to the nth term? Well, what does the nth term say? It says 4n. What does that mean? Remember, 4n. 4n means 4 times n. So, if I want the first term, where n is 1, we replace, a bit like the starter question, we replace, what is 4 times 1? 4. So the first term of this sequence is 4. Because the nth term is 4 times n, and I want the first term, which means n is 1, therefore 4 times 1 is 4. If I want the second term, and hopefully you're starting to think, well, n is 2, the nth term is 4n, what would that mean? That means I need to do 4 times 2, because I want the second term. 4 times 2 is 8. What would the third term be? Well, n is 3, so I would do 4 times 3, because the nth term is 4n, and 4 times 3 is 12. So you can see a pattern starting to emerge now. If I want the fourth term, n is 4. 4 times 4, because the nth term is 4n, and n is 4. 4 times 4 is 16. And how did I get the fifth term, or how will I get the fifth term? I just replace n with 5. So we're substituting in n as 5. So 5 times 4 is 20. So what I'll do is I'll just write above how I got those numbers, okay? So just above, I'll write how I got those numbers. I did 4 times 1. Here, I did 4 times 2. Because the nth term is 4n. And hopefully you're starting to see that, oh, okay, that's quite straightforward, yeah? It's quite tedious, quite straightforward. And we'll look at ways in which we can see patterns where we can make this quicker for us. But if I asked you, using this nth term, 4n, if I asked you what is the 100th term of this sequence, hopefully you would say, well, that must be 4 times 100, because I want the 100th term, which means n would be 100, and 4 times 100 would be 400. So the 100th term would be 400. Okay, moving on to number 2. Example 2. Generate the first 5 terms of 3n plus 1. So 3n plus 1 is what we call our nth term. Yeah, and what do we know? We know that our nth term helps us find any term in the sequence. So if I want the first term, what would n be? N would be 1. So we're going to take n as 1 and we're going to replace it into our nth term. So this is a little bit more involved, because what we're going to do is 3n, so n is 1, we're going to do 3 times 1, which is 3, plus 1 is 4. So the first term would be 4. Why is that? And I'll just put an arrow as to why that is. It is because we're going to replace n with 1. So we're going to do 3 times 1 and then plus 1. 3 times 1 is 3 times 1 is 3, plus 1 is 4. Okay. So we're taking this and we're replacing n with 1. And it's the same story. If I want the second term, n is 2. So again, I'm going to use my nth term, I'm going to replace n with 2. So I'm going to do 3 times 2, which is 6, plus 1 is 7. Okay? So that would be 7. Number 3. The third term. N is 3. 3 times 3 is 9, plus 1 is 10. N is 4 for the fourth term. Same thing, and hopefully you can see what's happening. We're going to replace this n with 4, so we're going to do 3 times by 4, which is 12, plus 1 is 13. So that would be 13. And at this point, a lot of students, they're like, I can see what's happening. The sequence is going up by 3. So they often just say to themselves, oh, the next term must be 16, because they can see the pattern. They can see the rule of the sequence. But let's just confirm, how would you get that 16? If you didn't spot the pattern, you'd replace n with 5. 3 times 5 is 15, plus 1 is 16. So if we just pause, and if we look at both of the two sequences that we've just created using the nth term. So remember, using the nth term, you just replace n with what you need. If you need the second term, you put n as 2. If you need the fourth term, you put n as 4. If we look at it, let's look at this first one. What is this sequence actually going up in? What's the rule? Well, this sequence is going up by plus 4. And this nth term is 4n. This sequence we just established is going up by 3. And the sequence nth term is 3n plus 1. 3n. And this is going up by 4 and it's 4n. So there's a link that we can make here, and we'll get to it in a few moments, but just be aware there's a pattern starting to emerge that whatever this sequence is going up by, there seems to be some link with the number in front of the n. This is going up by 3 and it says 3n. This is going up by 4 and it says 4n. Okay. And we'll come back to that because the next one is a little bit different. Because this has got something extra involved with it. So it says generate the first 5 terms of n squared plus 4. N squared plus 4. Well, what does n squared mean? N squared, let's just recall, means n times n. Yeah, you times it by itself. And what have they given us here? We refer to this, remember, this is what we call the nth term. And what is the nth term? An nth term is something that will allow you, it's an expression that will allow you to find any term in the sequence. And in this case, we would like to find the first 5 terms. So that means that we need when n is 1, when n is 2, when n is 3, because we're just doing the first 5 terms, when n is 4, and when n is 5. So we're going to take our nth term, and we're just going to go through and we're going to replace n with whichever term we're focusing on. So clearly we'll focus on the first term, n is 1. What is 1 squared? What is 1 times 1? 1 squared is 1, plus 4 is 5, yeah? Because 1 squared is 1 plus 4 is 5. I'm just replacing, I'm substituting n with whichever term I am currently looking at. So if I'm looking at the second term, n is 2, so that would be 2 squared. Well, what is 2 times 2? 4, plus 4 is 8. So the second term would be 8. And hopefully, maybe you're following along and you're ahead of me, because it is quite straightforward. N is 3. That means I do 3 squared. 3 times 3 is 9, plus 4 is 13. Next term, I want n is 4. Okay, n is 4. That is 4 squared is 16, plus 4 is 20. And the next one would be n is 5, because I want the 5th term. 5 squared is 25, plus 4 is 29. So that would be 29. Now, if we focus on this and sort of try to spot a pattern like we did a minute ago, this sequence, we're going from 5 to 8 is plus 3. Then we're going from 8 to 15, which is plus 5. Then we're going from, that's not 15, 13, sorry. We're going from 8 to 13, which is plus 5. Now we're going from 13 to 20, which is plus 7. And we're going from 20 to 29, which is plus 9. So if you refer back to the first definition that we discussed, if I ask you the question, is this sequence linear or non-linear? Hopefully you would say, this sequence is non-linear. This is a non-linear sequence. So we'll write that just for our notes. This is non-linear. What does that mean? That means that it's going up by a different amount each time. So it is non-linear. And it is non-linear because it is an n squared. This extra squared bit makes it non-linear. It's non-linear, and it's what we call, and you could add this note as well, it's a quadratic sequence. So if you're in the lower years, you might not know what quadratic sequence means, and you don't necessarily need to right now, but this just is a quadratic sequence. If you are in year 9, 10, you know what a quadratic is. And you know the quadratic is because it is squared, it's n squared. Okay. So interestingly, there is nothing in front of this n, and it's going up by a different amount. But when we were focusing on the previous 2 examples, we noticed that it was going up by 4. Example 1 was going up by 4, and it said 4n. And we noticed that example 2 was going up by 3, and it said 3n. And the reason this links is because these are linear sequences. Both of example 1 and example 2 are linear. Okay, which means they're going up by the same amount. So that little pattern that we're starting to see, where what it goes up by is what is in front of the n. Yeah, going up by 4 is in front of the n. Going up by 3 is in front of the n. That pattern only refers to linear sequences. Okay, so it doesn't refer to example 3 because it is a non-linear sequence. It's going up by a different amount. And we're going to link all this in later in the lesson. But for now, hopefully you can see to generate a sequence, and it looks like there's so much on my page right now. But hopefully you realise it's all quite straightforward. You don't have to put in these arrows with the n equals 1 and n equals 2. I'm just doing that for your notes so you can refer back to it. But you wouldn't have to do this much writing when you're just answering questions yourself. This is just for us to illustrate how it's coming about and what I'm actually doing. So if we move across to example 4, very, very similar. Generate the first 5 terms. So we've got n is 1, n is 2, yeah, because I want the first 5 terms. N is 3, n is 4, and n is 5. Of the nth term, which states minus 3n plus 4. Minus 3n plus 4. So you have to be careful here. The first note that we're going to add at the top, we'll just say note back. Okay. We'll say note back. If you do a negative times by a positive, okay, you do a negative times by a positive, you get a negative. Yeah, and I speak about this a lot. And the way that you can remember that is a mixture makes a minus. Okay, if you have a mixture of signs, so if you've got a minus times by a plus or a plus times by a minus, same thing. If the signs are mixed, they're different, you will end up with a minus always. Okay, and it's quite a handy thing to remember. So why have I written that down for you? Well, if we look at generating the first 5 terms of the sequence, when I want to get the first term, n is 1. So I've got to take my nth term, yeah, which is minus 3n minus 4. So I'm just going to illustrate how I'm going to get the first term. I'm going to do minus 3 times by n. Well, the first term, n is 1. So minus 3 times by 1. And then I'm going to take away 4. So I'm replacing n with 1. Okay, I'm replacing n with 1. And you just have to be careful. What is minus 3 times by 1? Well, 3 times 1 is 3, but we've got a minus and a plus. Yeah, we've got minus 3 and a plus 1. A mixture makes a minus, so that would be minus 3. So when you times minus 3 by 1, you get minus 3. And then we need to take away 4. And this is where students sort of get stuck. What is minus 3? Take away 4. Well, if I'm at minus 3 on the number line, and I take away 4, I'm going to go down more negative. So it's going to take me to minus 7. Okay, so it's going to take me to minus 7. So the first term would be minus 7. So that is how I have got my first term. I've replaced n. Same as the other examples, it's just a little bit more tricky because you've got a negative involved. So that's the first term sorted. Now, this is where I want to start to bring in what I was talking about a minute ago. When you are just doing term to term, when you're doing like the first term, second term, then the third term, we call that term to term. We're going just one extra term each time. Instead of having to take 2 and now do 3 times 2, or minus 3 times 2, which is minus 6, minus 4 would be minus 10. So this sequence here is minus 10. The second term is minus 10. Because I'm taking a 2 and I'm replacing it in with n, and I'm timesing it, I'm just being careful with my negatives and I'm making sure I work it out properly. But what have we looked at with those other 2 linear sequences? We saw what's happening to the sequence. Minus 7, minus 10. What's the pattern there? What is the pattern? It's going down by 3. Okay, it's going down by 3. So that's interesting. What's in front of the n? Minus 3. So hopefully you're starting to see that whatever is in front of the n, if the sequence is linear, whatever is in front of the n is the term by term rule. So instead of having to substitute in n is 3, which would be minus 3 times 3, which is minus 9, and then take away 4, which would be minus 13. Well, what happens if I just take away 3 from 10, minus 10? I would get minus 13. So when you're just doing term by term, it's easier just to realise whatever is in front of the n is what the sequence is going up or down by. So if we've got minus 3 in front of the n, this sequence is going down by 3. So once you know what the first term is, so you have to work out the first term, you can just take away 3 each time. So now I could just take away 3, I could take away 3 again. So I'm going to get minus 16. I could take away 3 again, and I'm going to get minus 19. And again, this only works when you're going from like the first term to the second term to the third term, term by term. But if let's just check if I was right. If I take n is 5 and put it into my nth term, minus 3 times 5 is minus 15. Minus 15 take away 4 is minus 19. So as you can see, going term by term, I got minus 19 a lot quicker by realising whatever is in front of the n is what the sequence is going up or down by. Okay, and we'll add that note later on. But it's something really important to spot. Okay, moving on. Example 5. Write down the 20th term of 10n minus 3. Well, if I want the 20th term, if I want the first term, n is 1. If I want the second term, n is 2. What would the 20th term be? Well, that means n would be 20. So then all I do is just take my nth term, which is 10n minus 3, and I'm going to substitute n is 20 into it. So I'm going to put 10 times by 20, because remember, 10n means 10 times by 20. And then I'm going to take away 3. So what would 10 times 20 be? Well, that would be 200. 200 take away 3 would be simply 197. So the 20th term in the sequence is 197. So we didn't have to work out the first term, second term, third term, and then keep going until we got to 20. All you had to do was realise, right, the 20th term, n is 20, substitute it into the nth term, which they gave you. 10 times 20 is 200, take away 3 is 197. Okay. So example 6. Write down the 300th term of the sequence. Well, if I want the 300th term, what does that tell me? That tells me that n is 300. And if my nth term is 2n plus 50, I simply replace n with 300. So that is just going to give me 2 lots of 300, because n is 300, because I want the 300th term, plus 50. Well, what does that equal? 2 times 300 would be 600. And then 600 plus 50 would be 650. So if I was looking at the 300th term of 2n plus 50, instead of having to work out every term and add on 2 in this case, I can just bang it in and I get 650. So, under this practice here, I've asked you to generate the first 5 terms of each sequence. So what we're now going to do is just explore more about realising what is in front of n can help us work out term by terms very quickly. So I'll do this first one for you and talk along while I'm doing it. I want the first 5 terms, so I'm just going to write out 5 lines so I know where I need to put my terms, okay? Well, this here, I want the first term. Remember, when you want the first term, n is 1. Okay? When you want the first term, n is 1. So, what is 2 times 1? Okay? 2 times 1 is 2, so the first term is 2. Now I could put in n is 2 and just do that way. 2 times 2 is 4. But what do we know? We know, and we can make this note now, whatever's in front of the n, whatever is in front of n, providing it's a linear, not a squared, is what the sequence is going up or down by. Okay, so whatever's in front of the n is what the sequence is going up or down by. So if we have got 2 in front of my n here, I know this sequence is going up by 2, and this is quite straightforward. Yeah, we can just see this. So the next one, without having to substitute n as 3 in, which is easy anyway, I can just realise, okay, I know it's going up in 2 because it's 2n, so I can just add 2 each time. So that would be 6, 8, 10. You can check, what's the 5th term? That would be 2 times 5. 2 times 5 is 10. So it'd get you the same answer either way. Okay, next one, same thing. I want the first 5 terms, okay? 3n. So you always need to work out the first term using n as 1. And then from there, you've got 2 methods now where you can work out the terms. So 3n. n is 1 for the first term. So what is 3 times 1? 3. Second term, n would be 2. 3 times 2 is 6. However, what do we also know? What do we know the sequence is going up by? 3. So I could just add 3. 9, 12, 15. Either way, whichever method you pick will get you the right answer. Okay. So hopefully you can see those first 3 are quite straightforward. So I'll just leave you to do the second one. First term, n is 1. 4 times 1 is 4. We know this sequence is going up by 4, so I could just add 4 each time. Or you could substitute n is 2, n is 3, n is 4. So adding 4 each time would simply give me this. Hopefully you managed to get that. Where this, what is in front of the n, is quite useful and saves a lot of time is for the next couple examples. Okay. If we look at 4n plus 1, well, let's work out the first term. n is 1. What is 4 times 1? 4 plus 1, 5. So the first term would be 5. When n is 1, the first term is 5. What do you know this sequence is going up in? Hopefully you're starting to see a pattern. This sequence is going up by 4 because 4 is in front of n, which means I know it's going up by 4. So I could simply add 4 now, rather than substituting n as 2 in. So let's do both ways just to check. If I add 4 to 5, I get 9. Or if I said n is 2, 4 times 2 is 8, plus 1 is 9. So it gets you the same answer. But a lot of the times it's quicker. If you're doing term by term, the next term, the next term, the next term, just work out what it's going up by looking at the number in front of n, and just add that on or take it away. So if I add on 4 to 9, I'll get 13, 17, 21. Okay, I'm just going to let you have a go at those now. So you always need to put n is 1 in to get the first term. You should always work out the first term. So this next one, 4n plus 7. Well, the first term would be 4 times 1 is 4 plus 7 is 11. So the first term's 11. And hopefully you can spot this sequence is going up by 4 because it says 4n. So if it goes up by 4, the next one would be 15, 19, 23, and 27. And then I've just thrown in a couple with some fractions just to try and make sure that you're confident with the method. We've got a half n plus 10. What do we know this sequence is going up by? It's going up by a half. Okay? We know whatever, at this point, whatever's in front of the n, that's what it's going up by. Let's get the first term. So we're going to say n is 1. What is a half times 1? Well, that is just a half. And what's a half plus 10? Well, a half plus 10, you could think of that as 0.5 plus 10, is 10.5. And this is where knowing that it's going up by a half is really useful. If it's going up by a half, what would the next term be? Well, 10.5 plus 0.5 would be 11. And then it's going up by a half again, so that would be 11.5. Then a half again, 12. And then a half again, 12.5. So as you can see, rather than like here, this is the third term, n is 3. Rather than saying, right, what's half of 3? Half of 3 is 1.5. What's 1.5 plus 10? 11.5. You can just get it by realizing it's going up by a half. Okay, so that's really, really useful. And by knowing this fact, sequences 2, is going to start really relying on that understanding that whatever is in front of the n is what it's going up by. So we'll just finish off these next two. Same thing. This one's going up by half. I can see that. It's in front of the n. So I just, as long as I can find the first term, I can just add on a half to get the next 4. Getting the first term, what is 1 times a half? Well, that is 0.5 is a half, plus 5 is 5.5. And now I know this sequence is going up by a half, yeah? Another way to write half, remember, is 0.5. So that would be 6, 6.5, 7, 7.5. And then finally, we just have to be careful on this last one. What is in front of my n? Minus a half. What does that mean? It means it's minus 0.5. It's going down. My sequence is going to be going down because it's a minus. If it is a minus, it's going down. It's going down by a half. So let's work out the first term first of all. Okay, what would the first term be? The first term would be minus a half times 1. Well, what is minus a half times 1? That would be minus 0.5 because a mixture makes a minus, plus 5, and this is where you have to be really careful. What would minus a half plus 5 be? Well, if I was at minus 0.5 on a number line, and 0's there, and I'm adding 5, it's going to get me, hopefully you can see, to 4.5. Okay? So, it's going to get me to 4.5. So my first term would be 4.5, and it's going down by a half. So if I'm going down, I'm taking away a half. What's 4.5 take away a half? 4. 4 take away a half. 3.5. 3.5 take away a half. 3. 3 take away a half. 2.5. Okay, so generating sequences, what do you need to be relying on? What key facts and key skills do you need to know? 1, realizing n represents the term that you want. So if you want the 4th term, n is 4. If you want the 10th term, n is 10. If you want the first term, n is 1. Secondly, you need to be able to substitute. So you need to be able to replace the letters with a number and work it out using basic BIDMAS. And thirdly, the key to sequences is realizing for linear sequences like these, whatever's in front of the n is what is happening, what is the rule of the sequence. So if it's 2n, it's going up by 2. If it's 4n, it's going up by 4. If it's a half n, it's going up by half. If it's minus 4n, it's going down by 4. Okay, so that's key. So just to finish, I've put here, it wants you to work out not the first 5 terms, just a term. So find the first term of the sequence. Well, for the first term, n is 1. So we need to do minus, if we've got minus 13n as our sequence, nth term, we're going to do minus 13 times by 1 plus 3. So what is minus 13 times 1? Well, that would be minus 13. Minus 13 plus 3, take you back up the number line. So the answer to that would be minus 10. Because if you're at minus 13 and you add 3, takes you to minus 10, going back towards 0. So I'll leave you with those to have a go at. And in sequences too, we're going to look at how do we go from a sequence, so they give you a sequence, and we're going to do the opposite, where you have to work out the nth term. So you have to find these nth terms given the sequence. Okay. Thank you to all of those that have tuned in and watched, or watched it on playback. Have a go at those ones. I'll link some more questions in the description as well for you to have a go at. That will let you practice generating a sequence, and I will see you in the next one.